Hello everybody, welcome to another Zabbix video. This time I'm talking about disk space monitoring, but not in a classical sense, more like a folder monitoring. What's the consumed space for your data directory? And what I mean by data directory is the use case is how to protect yourself of making mistakes while configuring Zabbix. I personally, I create a master item. Sometimes it collects like few kilobytes of data, sometimes it's more than 64 kilobytes of data, and by accident I can leave that item on the inside the Zabbix instance, which is unnecessarily fulfilling the disk space. And so I want to identify those situations as fast as possible, not wait till the database is full without that garbage values, but in the very moment I create those items, 1 hour later, Zabbix can notify me, hey, there is some noticeably different increase going on, and we want to be more in charge to solve the things at the very root level. Okay. What I will start, I will highlight that each database flavor, database type, is having a data directory. With the MySQL, it is data directory is var lib Zabbix, and inside this directory we have some other folders which match the database name, here Z60 Zabbix. And when we create a database inside the MySQL engine, then mainly the data goes under that folder. Let's navigate to the Zabbix, and here is bunch of tables, 200 tables, more than 200 tables in the Zabbix 7.0, and these are the files which is actually receiving the updates and getting bigger and bigger and bigger. So I would like to monitor the really how this folder is getting bigger. And let's cover also the Postgres situation. Inside the Postgres, it is there is a little bit different approach. Inside the Postgres, we at first need to run this database command, select .name OID from PG database, and it prints the OID per database folder. And now if we navigate inside the data directory of the actual Postgres server, something like PG database, inside that directory we see the same folders, and this is where the real data goes written in for the Postgres server. So in this tutorial I will show how to monitor this folder. So let's go here, cd, and this will be the folder name, and we will also demonstrate what happens if a user makes a mistake. This folder will really start to increase in size. Okay, the next step, so I will copy this thing to the clipboard, copy, opening the Zabbix interface. This is my host object which takes care of that Postgres server. Create new item. The active checks will be used, and here we will use an item key which is called VFS directory size. And here inside the square brackets I will put my directory. Since I have it running already, I will put in double quotes to make it more unique. The output is standard bytes, and we will monitor every 5 seconds for the sake of demonstration. And let's call it Z7 size test, and tags episode 57, that's the number of the video, and that's it. So now I'm measuring the total size of this directory add, but I prefer not to see the megabytes. I really like to work with the delta, how it's increasing every 5 seconds, and for the delta we will create dependent item delta of Z7 test, and this will be also measured in bytes, delta Z7 test, something like that. tags episode 57 and pre-processing, and there is pre-processing step, which is simple change, not change per second, but simple change, and that is everything. Add. So I have two items, and probably the first one collects already. This one it measures the size of the folder, and the other one is measuring the increase every 5 seconds. I will open the other tab, latest data. I have prepared that stage as already. Apply, closing this filter, and here you go. Like the total size of the folder is 7.something gigabytes, and the increase happens over here, like every 5 seconds. I receive around like 48 kilobytes of data, not too much. And we will let's maybe wait a few more seconds so we see a little bit how it's not changing at all, because 1 minute later I will start to create some damage to see how the impact is represented inside this graph. Let's put over here and refreshing the page, click. And we see like maximum here is 128 kilobytes, and it's going down. And okay, while this is loading, I will also go here and now creating the damage. Data collection hosts will open the third tab and create something like create host episode 57 and disco. Click, and that's everything. Add episode 57. Items, create item, and one way how I can think to start to generate noise in database is by using the HTTP agent item. Let's grab https blog.zabbix.com. It's an excellent website. I suggest to visit it. This is URL, and we will fetch this thing. And what Zabbix can do, it can save the first 64 kilobytes of an HTML file. Okay, and what we will do, not HTTP request code not required, and the frequency will be aggressive, and that's like the part of my mistake. What if a user tells every 3 seconds, let's fetch the whole HTML file and add. Okay, let's see the graph over here. So here we see the maximum is 128, and it goes this way. Already. And I will a little bit multiply this thing at first, actually, to measure how big is the HTML. I can click dependent item, size of HTML, and in bytes, click pre-processing, and there is an excellent pre-processing step. JavaScript return value dot length, something like that. Let's test if it even works. ABC, apply, test. Yes, the length of ABC is 3. Okay, add, and 64 kilobytes is actually not enough to make a noticeable impact, but I can make more mistakes, like create dependent item. This will be called 1. Click, and let's store it in the log. Add. So I'm by creating dependent item, I really mirror the data. 2, click, to add. So let's create 3 more. 3. I'm cloning the dependent item. Clone 4, and one last one. Click, clone, and 5, and 5 over here. So what happens right now? The HTTP agent item is fetching the website every 3 seconds. it saves in the database first 64 kilobytes, and it mirrors the data to the item 1, 2, 3, 4, 5. So the formula would be 64 multiplied by 6. This is the growth. Every 3 seconds the database grows by 384 kilobytes, and since there is like in minute there is 20 batches. Right now it's the frequency is 3 seconds, enter. Then it kind of means 7, it looks like 7 megabytes per minute. I don't know if that is true, but yeah, now going back to the graph, what we see here, it was 128 kilobytes long time ago, and now the database, like the speed of growing the database, it's like really not only 2 times more, it's actually 3 times more. And how, like, I made such mistake in 2 minutes just by like maybe forgetting to shutting down the history. Like usually for raw items we use this do not store history. That's like the best practice. We have a lot of dependent items, and then we remove the historical data for the master item. That is kind of everything. Okay, for the sake of the test, we can also create a trigger. Create trigger, add, and select, and we would select I'm on the wrong host, sorry for that. Click, and going back on the all hosts, and this is the one. Items, episode 57. Okay, triggers, create item, add, click, test, delta of Z7, and here we would say over bigger than something. Better like see the raw data. I'm currently not sure. So this is the units, not units, but the raw data. So here we would say like it was 100 kilobytes normally. So let's grab this thing, put it over here. And the best function for the task is looking for the minimal value, I would say. If the minimal value in the for the like last 20 metrics. Okay, last 20 metrics would be ideal in this scenario when I fetch every 5 seconds, but in real life you would say you are fetching every 1 minute. So then we would say like smaller number. So if last 10, if the minimal value of last 10 items is bigger than like 120 kilobytes, then like total increase, I mean like increase per batch is bigger than like something like that. Allow manual close, and this would be the total trigger to identify the problem. Add, and if we see here 1, 2, 3, 4, 5, I would almost hit the trigger right away if I would lower down the threshold just a little. Let's try total and increase, click, and let's say like this. So 10 batches update, and here you go, it is in the problem state. If we check the total problems of this host, click, then it's fluctuating right now, it seems like, and like after some seconds it would go back again, if we check the raw data, we see the threshold. Just one sample dropped below and it resolved. But if we look how it was looking 5 minutes ago, it's completely different. And yeah, this is the way to detect an increase of the data folder, or more precisely like a database folder. If you have like one precious database object and you treat that as a gold, that's like your precious, and you don't want to save any garbage in the database, then it's a nice mechanism to identify your mistakes as fast as possible, and so we can keep all the data as light as possible. Okay, if you find this video helpful, give it a thumbs up. By the way, this video is a part of my playlist how I use Zabbix. If you want to see more videos which is related exactly to my personal experience, check the channel's playlist, and there is such playlist. And goodbye.